Hey, welcome back to another video of Chem with Com. And yeah, let's get this started. All right, so today we're going to be talking about polyatomic ions and nomenclature. This is the next three videos. I know it's a weird grouping, but I think this works. So let's take a look. All right. First, let's explore, three-part video. First part is going to be polyatomic ions and what are called neutral compounds, right? Because we have compounds that are charged and neutral compounds. Let's take a look. Okay. We viewed this before, but these are polyatomic ions. Let's break down that word. Poly means many or more than one. Many atomic, so many atoms that are ions. Ions have a charge, right? So that's what we're going to focus on is these polyatomic ions because we're going to need them for the nomenclature part. But let's look at these, right? Ammonium has a plus, a 1 plus, which means, remember, if you have a positive, that means you lost a negative charge. So you lost an electron. So these two lost one electron collectively, right? So nitrogen has five valence electrons. Hydrogen has one valence electron. So one, 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 one. So this is nine electrons, but that positive sign means you lost an electron, so you only have eight electrons left. All right, hydronium, similar. Peroxide has a 2 minus charge. Hydroxide has a 1 minus charge. Carbonate has a 2 minus. There's phosphate with a 3 minus. There's something called phosphite that also has a 3 minus, right? So it's many atoms with a charge, right? And you have neutral compounds too, right? H2O, right? There's no plus, no minus. So no charge, right? So you want to look up and to the right of the molecule or the atom, and if there's no number there or no symbol, no plus, no minus, no numbers, those are neutral atoms or neutral compounds. All right. So polyatomic ions will usually stay together, right? These don't blow apart, um, and they behave like monoatomic ions, meaning a positive is a positive no matter what. A negative is a negative no matter what, right? Um, and collectively, the molecule has lost or gained one or more electrons, just like we saw earlier. Like this one minus means it collectively, all those three nitrogens gained one electron, right? Not every individual nitrogen got one electron. N3, the total molecule, got or picked up one electron. Where carbonate, it's a 2 minus, it picked up two electrons. So a carbon and three oxygens are together and they're sharing electrons, but collectively they picked up two extra electrons. All right. So we did this before also, but we're looking at what are called fixed charge ions, right? Everything in group one is going to be a plus one, or sorry, let's do a one plus. I like the way it's easier to keep track of for me. So 1 plus, everything here is 2 plus, everything here is 3 plus. This is, we don't know because it's, it could go either way. This is 3 minus, 2 minus, 1 minus. This never has a charge. Two other atoms I want you to remember are zinc 2 plus and silver 1 plus. It's like a stair step, right? You go down the stairs, you start at 3 plus of aluminum, go down the stairs, you're now at 2 plus, and then you go down the stairs again, you're at 1 plus. So aluminum 3, zinc 2, silver 1. Okay, these are what are called fixed charged ions. And um this is gonna play a lot into the nomenclature thing, so we're going to need to really focus on this. So fixed charge ions, and there's also something called variably charged ions, meaning they can have different charges. One single atom or one single ion can have two different charges depending on the conditions they're in, right? One, like for example, iron can have a 2 plus, meaning it lost 2 electrons, or it could be a 3 plus, meaning they lost 3 electrons, right? So everything listed here are fixed charge ions. Everything that's not here are going to be variably charged ions, all right? All right, so here, let's start making what are called ionic compounds, and we want to make them neutral. Neutral compounds mean no charge, right? No charge listed. And basically, we're going to ionic bond, we're going to do a metal and a nonmetal. The cation is the positive, the anion is the negative, and the cation's the metal. All right, the anion's going to be the nonmetal. The total charges should add up to 0. We can do what's the crisscross shortcut. I just call it the crisscross applesauce, and then use the empirical formula, which we learned before. Basically, same ratio of atoms with lowest subscripts. Okay. In this class, ionic compounds will be made up of one anion and one cation. Later on, you figure out all sorts of stuff can happen, but for this class specifically, we're going to have one anion and one cation. Okay, so here we have a sodium, which we know is a 1 plus based on our periodic table, right? Sodium, 1 plus, chlorine, 1 minus, and we have the 1 plus and 1 minus. Since you have a 1 plus and a 1 minus, that adds up to 0. That's a neutral compound. All right. So, yeah, we only need one of each. So it becomes 1 sodium, 1 chloride. All right, magnesium and oxygen. We see that, hey, there's a 2 plus and a 2 minus. So that gives us a 2 plus and a 2 minus. That equals 0, another neutral compound. That's our objective here, is we want to combine ions to make neutral compounds. So because we only have one magnesium and one oxygen, that's all we have. All right, so now let's change it up a bit. Here, calcium and fluorine. Calcium is here. Fluorine is here. But you see calcium has a 2 plus. Fluorine has a 1 minus. Let's try to figure this out. Let's do it over here. So calcium, 2 plus, and a fluorine, 1 minus. Well, that's a 2 plus and a 1 minus. That equals a 1 plus. Not neutral. Uh-oh. Something ain't working right. All right, so because what we're going to do, because it's not neutral, we're just going to add more ions until it's a neutral compound. So let's try it out. So we're not going to add any more calciums because we're already at a 2 plus, but we're all going to add another fluorine. Now we have 2 plus and 2 1 minuses. That's going to be 0. Neutral compound. So we have 1 calcium, 2 fluorine. So we write it as 1 calcium, 2 fluorines. Another way to do that is that crisscross applesauce method, right? So Ca 2 plus F1 minus. We're going to take these numbers, the charges, cross them over, and it becomes Ca1, which you don't put the 1, F2. All right. So if we look at iron, this specific iron is 3 plus. This specific oxygen, or all oxygens are 2 minus, right? Oxygen here is 2 minus. Iron's over here somewhere, right? But iron is a variably charged ion. This specific one is going to be 3 plus. So if we take the iron 3 plus and the oxygen 2 minus, you bring the numbers down in a kind of a crisscross pattern where the 3 iron 3 plus is now on the subscript of oxygen, and the oxygen 2 minus is now in the subscript of iron, which gives us basically 2 iron atoms for ions, O2 minus, O2 minus, O2 minus. Here we have a 3 plus, 3 plus, 2 minus, 2 minus, 2 minus, that equals 0. So another neutral compound. So iron 3 plus and oxygen 2 minus, the correct formula is Fe2O3. All right. So now we can start using what are called those polyatomic ions, and we treat them exactly the same way. So we have a 1 plus, we have a 1 minus, and that gives us a sodium nitrate, NaNO3. Here we have a 2 plus, and it's, sorry, it's supposed to be a 2 minus there. I think got a little off track. But that's going to be 1 molecule, sorry, 1 atom of magnesium, 1 molecule of SO4, which is sulfate, and then you put them together, it's magnesium sulfate, because 2 plus and 2 minus add up to 0. All right, here we have what's called ammonium. It's a 1 plus. Oxygen is a 2 minus. So we could do a couple tricks. We can bring it down, this one over here. But because it looks weird if we did this, you wouldn't know what that is. It looks like NH42, right? That's not going to be it. We have to put it in brackets, right? That means there's 1 nitrogen, 4 hydrogens to make ammonium, but we have a total of 2 of them, right? So since we're using 2 of them and 1 oxygen, it's right here. This is the formula for a compound with ammonium and oxygen, right? And these are NH4 is a polyatomic ion, but we treat them the same way as any other ions. Again, we're trying to make neutral compounds. Here, let's do the same thing. Oh, it's over here actually. We took the calcium 2 plus and we brought that 2 down to the subscript of calcium phosphate. And this is written a little differently. Let me rewrite that. Ca3 PO little 4 and then 2. Right? Because there are 3 calcium ions, 2 phosphate ions. So let's draw this out. Ca2 plus, Ca2 plus, PO4 3 minus, sorry, there's another calcium. PO4 3 minus. All right, so we have 2 plus, 2 plus, 2 plus, 3 minus, 3 minus, that equals 0. So that is a neutral compound. So the formula is going to be 3 calcium ions, 2 phosphate ions, 3 and the 2. So this is going to be the formula for calcium phosphate. All right, let's look at the formula for sodium and oxygen. So I'm going to write the charges here. This is 1 plus, O2 minus. So because we're trying to make a neutral compound, this has to be Na. We need 2 positive charges because that oxygen has a negative charge, 2 negative charges. All right, barium and nitrogen. If you look at barium and nitrogen up here, right, barium is a 2 plus, nitrogen is a 3 minus. So let's take a look there. Barium is a 2 plus, nitrogen is a 3 minus. We bring those down, it becomes Ba3N2. All right, now we're going to start getting into polyatomic ions, and you're going to have to get familiar with these. So there's an assignment that we did on the take-home quiz, I believe number 1 or 2, that tells you, hey, we need to do these polyatomic ions. But yes, sodium 1 plus, hydroxide is OH 1 minus. We only need one of each to make a neutral compound, and it's NaOH. Ammonium NH4 1 plus, sulfur S2 minus. So again, ammonium is the 1 plus. Sulfur is over here with its 2 minus. It's a fixed charge ion. So let's bring those down. It's going to be NH4. We need 2 of them, so we need the parentheses and then S, right? This is ammonium and sulfur together. Now we can put together 2 polyatomic ions. This is NH4, 1 plus. Carbonate is CO3, 2 minus. Let's bring those numbers down. Remember, crisscross applesauce, so it becomes NH4. We need 2 of them, so we put that in parentheses, and then CO3. And this is the compound containing ammonium and carbonate. But that's a neutral compound. Remember, we're always trying to make neutral compounds. So we have to add atoms, or sorry, add ions or polyatomic ions to make sure that all the charges add up to 0. All right. That's it. Thank you very much, and I will catch you next time. If I can get out of here.